So, einen wunderschönen guten Abend. I know I pass on to English in a few seconds, but let me allow you a very warm and German herzlich willkommen hier bei uns im House of Switzerland zu einem für uns ganz, ganz spannenden Panel heute Abend. Ich begrüße ganz herzlich auch das Publikum online und möchte mich Ihnen vorstellen. Mein Name ist Britta Thiele-Klapproth. Ich gehöre zusammen mit meinen Kollegen hier zu denjenigen, die dieses Projekt für Sie realisiert haben, also dieses House of Switzerland. Ich glaube, ich habe ein paar bekannte Gesichter gesehen und auch einige neue. Wir wollen mit dem House of Switzerland hier in Stuttgart einen Platz für Begegnungen schaffen und wollen Baden-Württemberg und die Schweiz, die in vielerlei Bereichen so eng verbunden sind, einfach durch den innovativen Ansatz noch näher und gemeinsam voranbringen. Das heißt, wir wollen Baden-Württemberg stärken und wir wollen die Schweiz stärken und die Erfahrung der letzten 3 Monate, wir sind jetzt hier auf der Zielgeraden, gibt uns recht und sagt, das war ein großer Erfolg. Wir haben hier verschiedene Technologieabende kuratiert, von künstlicher Intelligenz zu Smart City, zu personalisierter Gesundheit. Und heute Abend geht es um Drohnen. Und bevor ich an Anja Lange übergebe, die den Abend für uns heute moderiert, möchte ich Ihnen ganz kurz sagen, dass für mich nicht als Wissenschaftlerin, sondern dass ich Baden-Württemberg und die Schweiz im Bereich von Drohnen als hochgradig spannend wahrnehme. Wir haben Experten hier, die vor allem zur Regulierung was sagen können. And I'm looking very much forward to the very interesting and highly experienced high-level discussion tonight and pass on the mic to Anja. Thank you for being here.
Well, thank you so much, Britta. So this evening is going to be in English, so I'm just gonna say a quick guten Abend für alle Deutschen and otherwise welcome here in the House of Switzerland. Welcome to this panel. My name is Anja Lange and I'm a moderator here from Stuttgart, Germany, and I've been to the House of Switzerland now in the last couple of months quite a lot. They have to fill up the Swiss wine, you know, because of me. No. So in the next 1.5 hours, we're going to focus on the future of aerial robotics. Very, very interesting topic, as Britta already said. And I've heard that many aviation experts, they are promising or saying that the 20s, this decade is going to be the next golden age of aviation and of flight. Let's see, this is exactly what we're going to talk about, if it is really like this. Technologies are definitely evolving, also we're going to find out more about this. And it seems like this future where everything's about drones and drone powered is not so far anymore, but let's see about this. For this we have some really amazing experts from Switzerland, from Germany here with us. So first we're going to listen to 2 short presentations from 2 professors who are going to show their research, and that is followed by a panel discussion. So I'm going to invite all the experts here and we're really going to discuss this future. Obviously, I would like you to ask questions as well, so please use this opportunity. We do have a microphone here, and ask all the questions that you're interested in. The same counts for our online audience, so a very warm welcome to you as well. I already heard that we have quite a lot of people that are watching us online as well, so if you have any questions and you're watching it on YouTube or Instagram, please just comment in the little comment section if you have questions, and I will also ask them here on stage. This is how hybrid events work. It's great. And if we then still have questions and still more interest in the topic, then we invite you over to our, food and drink corner for a nice glass of Swiss wine and some cheese to discuss the topic further. And now let me welcome from Lausanne, Professor Dario Floriano. He is the director of the Laboratory of Intelligent Systems at the Swiss Federal Institute of Technology in Lausanne and the EPFL. He is also the founding director of the Swiss National Center of Competence in Robotics. It's a research program that brings together all the different labs across Switzerland. And he already helped spinning off 2 startups, 2 companies, that are, really involved in the drone business. And his research is really going into the biological inspired robotics. It's really, really interesting. He's going to show us a lot about this and about his research. And I'm actually really excited. Haven't seen the presentation yet, so I'm really excited. Please, with a very warm applause, welcome Professor Dario Floriano. Welcome.
Does it work? Okay, very great, thank you. Great, thank you for joining us today, and it's a pleasure to be here. Thank you very much for the invitation. So, today I will be speaking about the science, the technology, and the future of drones in the next 10 minutes. And what you see here is an artistic rendering of the goal of my lab. What you see here is lots of drones. They are bio-inspired, as Anya was saying. And most importantly, they are capable of flying in environments that we share with them. So they must be able to avoid obstacles, or at least to be resilient to obstacle avoidance. They must be safe for humans to operate, both in terms of how you use them and what happens if they go out of control or they get in touch with humans. And so what I do actually is not that I do not mimic biology. I just try to capture principles from biology and translate them into engineering solutions. I'm going to show now to you a couple of examples of how we started from a research question in biology, or taking inspiration from biology, and we turn that into a research result and eventually into a company. I will then tell you something about our current research, which could become the future of drones, possibly. A lot of, actually, all the stuff I'm going to show to you today has been done by my researchers, PhD students and postdocs, who are really great. So you see my name there, but there should be lots of other names. Just I didn't have space to put all of them. So let me start with one early research questions we had. At that time, that was back in 2009, 2010. I was interested in replicating the amazing capabilities of insect eyes. Insect eyes are amazing because they have almost 360-degree field of view, and they are super lightweight, and they are super soft. They cover their brain. When an insect collides with an object, essentially they hit the object with the brain, with the eyes, and they deform and they still function. And so at that time, I was fortunate to have a team of researchers across Europe, including the Fraunhofer Institute here in Germany, in Jena. And our goal was to reproduce these, make an artificial compound eye. And what you see here in this slide is what we obtained is a cylindrical compound eye. You say, well, it's larger than the insect eye. It's yes, it's true, it's larger. It's cylindrical, so it's not exactly spherical as an insect eye, but the advantage is that it can be 100 times faster than an insect eye because we use electronic speed to process the signal. Not only, but it mimics precisely the vision system of a fly. And at that time, we used neuromorphic engineering, which my colleague Davide Scaramuzza will probably talk about in the next slide. It was a little bit too early at this stage, but now it's becoming very, very good. Neuromorphic engineering allows you to extract signals and process them at an amazing speed that conventional digital computers cannot do that. Short story is that we achieved this amazing eye, just 700 small eyes, just like the insects, and less than 1 millimeter. Now, it turns out that the very first artificial compound eye that was found in nature, evolved in nature, was actually cylindrical. And it was used by trilobites living 250 million years ago on the ocean floor. So just like the same size, the same shape of our first artificial compound eye. We discovered this only later on. So it's a nice convergence of biology and engineering coming to the same solution. As we had this compound eyes that was capable of extracting motion, just like insects do, and detecting distances from objects, we put this on a small drone, a winged drone, and we showed that with very few lines of code, essentially extracted information from the visual field of view, just like insects do, we could fly this drone that was not only capable of avoiding obstacles, trees and houses, but also use the same eyes to maintain altitude from the ground, essentially avoiding the ground, always with the same few lines of code. And at that time, we actually did a lot of work. It was early 2010. We said, wait, here we have something that we could make drones that can fly autonomously and then land back next to an operator. And so with my PhD students at that time, we founded a company. It was called the SenseFly, because the drone was capable of sensing the environment and fly autonomously. And we were one of the very early companies in the field of drones at that time. SenseFly became very successful. It was capable of sending drones for inspection of agriculture fields or large spaces. Today is part of the Parrot Group. It still exists. It's still next to EPFL in Lausanne, and is a leading company in winged drones used for inspection agriculture in all the major markets in the US, Europe, and Asia. Okay, then at around 2010, I sent a student, Adrien Briot, to Harvard University to do his master project. And his goal at Harvard University was to measure the behavior of insects flying in very cluttered environments. So he was filming these insects colliding with walls. When he came back, I realized, wait a minute, these insects are not avoiding the obstacles. They're just colliding head-on, withstanding the collision and carrying on. So we thought about this problem, and so we said, that's amazing. And so this is Adrien, and we came up, my researchers actually came up with this new drone, which had a protecting cage which was freely rotating around the inner propellers. And that was great, because the inner propellers were capable of maintaining the drone stable without any special control by simply aerodynamic forces, while the outer cage was absorbing the collision and freely rotating. And so we could fly this drone in a forest with just a magnetic compass. It would manage to fly through the forest while just hitting the obstacles and flying through. Here you see the perspective from the perspective of the drone. The drone was not using vision; was just flying, following the magnetic compass. And so, and that's also very safe for humans. This is Premek, one of the engineers who developed this drone. And so it's very safe for humans too. And so I said, hey, that's great. We have a drone capable of flying in cluttered environments, super safe for humans. You don't need to be an extra super pilot. And so my students founded a second company called Flyability, which today is a leader in inspection drone for cluttered environments like industrial boilers, tankers, oil tankers, bridges. And one of the speakers later on will speak about the next product and how this company is developing these days. So the company, I'm very glad that is more than 5 years old, has been nominated one of the scale-up companies in Switzerland, one of the top scale-up companies. These are companies that have went through the startup stage, and now they are on a very steady growth path to become a major company. So I'm very proud of my students of this achievement. So what are we doing these days? One of the possibly next killer applications, if regulations allow, and if the people are interested in this, is to deliver objects through the air. And what you can see, there are many companies, and some of these are no longer there, like Amazon, that are trying to do this. But when you look at these drones, because of the law of aerodynamics, they tend to be very large. In order to carry a load, you either fly very fast or spin the propellers very fast, or you have very large aerial surfaces, so wings or propellers. And for that reason, since you cannot fly faster than a certain amount of kilometers per hour, these drones tend to be quite large. But if you think about delivery of parcels, you tend to think of the post officers giving you the parcel in your hand. So how can we manage to do that in a safe way? And so again, we looked at how insects unfold and fold their wings. And we came up with a new concept of a foldable drone that can, unfold when you don't use it, and you can put it away in very small space, like in a drawer, or you can fold it around an object, and so essentially it operates like the wrapping paper around a parcel. What you see here, the drone, for example, you can send it to a person who is stranded in a building after an earthquake or something, and the person can simply grab the object, open the drone, and get the parcel, for example, emergency kit. So that's something that maybe if one day we are allowed to deliver to persons, we could use. Another interesting thing is drone swarms. I believe there will be a lot of drone swarms in the future. Now you say, what's new about drone swarms? We already see these slideshows of drones. In this case, Intel 50th anniversary, 2018, and they had 2018 drones up in the sky. Now you see many of these days. The problem is that these drones, although this is clever in terms of software and hardware, these drones are not autonomous. Each drone is controlled by a computer on the ground, and the computer controls precisely the trajectory of each drone as if they were pixels, so that they perform a certain motion so they don't collide and they display a new image. But if you look at the way in which animals fly, for example, birds, how they flock, is that they do not have a central computer telling them where they go. We know now that they use vision and they monitor the position of their neighbors. They approximately monitor, apparently, something between 5 and 7 neighbors. Plus, they look also the outer perimetry of the flock. And essentially, they use only local rules. They do visual recognition of the other agents or birds, and they use local rules. And so with my students, we came up with drones that have omnidirectional cameras on board, and they use machine learning to recognize the other drones against any background. In this case, on the sunset, it could be against trees. What you see, these are only 3 drones. It's not we cannot talk about a flock or a swarm yet. But all these drones, they do is that they don't use GPS. They look at each other, then they self-organize to design which trajectory they move. We also most recently look at how these drones can flock together and fly through obstacles, and then reunite at the end with this artificial forest, so to speak. So I believe this is something that we will see more in the future, having more drones that autonomously fly together. Now, I've shown to you some work with quadrotors, and then what we are working on recently is to achieve the amazing agility of some birds of prey, as in this case the goshawk or the falcon. What you see is that these birds can manage to achieve very sharp turns, or they can fly very slow, by morphing their wing and tail. And so we are now developing feather drone. You see here one of our prototypes that are capable of morphing their wing and tail to perform very agile maneuvers. Therefore, they also make the problem of controlling this drone super difficult. In this case, the feather drone that you can see here is controlled by a very skilled pilot. But what we are doing now with my colleague Davide Scaramuzza and PhD students is to make this completely autonomous. So this is the next challenge. I want to close my presentation by saying that in Switzerland we have a very fertile ground, and with a lot of research happening in Zurich, in Lausanne, and other institutions in the field of drones. And over the years, recent years, I must say, a number of companies that develop new drone software and hardware solutions, and we have established companies that you see on this board that develop services or components for drones. So it's a great place to be for doing research and for doing business. And one of the reasons I just want to say is not only that we have great research institutions like EPFL, ETH, University of Zurich, and instruments like the Robotics Center that can support many of these projects for a longer period of time, but also we have a very flexible regulatory agency, the Federal Office of Civil Aviation in Switzerland. The first time we operated this drone, it was 2009, 2008. We were flying these drones up in the sky, and then we asked ourselves, are we allowed to fly these drones over the campus? And so we said, who should we ask? We called the Federal Office of Civil Aviation, and we said, can we fly these drones? And they said, drones? Wait a minute. Drones at that time were just unmanned, dangerous drones with weapons. Wait a minute, we come down from Bern, they came down to Lausanne, and they looked, oh, that's very interesting. So, and very easily they gave us a letter of permission, you see here, that allowed us to fly over the campus. Of course, we had to fulfill some safety requirements, but they allowed us to fly, and it was great. And over the years, they developed a very nice environment where researchers and companies can benefit from special regulations that allow us to test new rules. And I would like to conclude this with thanking also the pragmatic aspect or attitude that we have in Switzerland. It is our former councillor, Doris Leuter. What she said is, we must first understand technology before we regulate it. In some countries instead is, first we set the rules, you cannot do anything, and then you develop the technology. So it's this pragmatic approach also that allows us to go from research to so many companies. Thank you very much for your attention.
Thank you so much. You can take it and give it to David in a second. Thank you so much for this quick overview. I think there are so many topics that we can dig deeper into. That's what I want to say. Thank you for now. And in a second, we will welcome you for the panel discussion. But first, we already heard from Dario that Professor David Scaramuzza is here as well, and he will also hold a very short presentation. He is a professor of robotics and perception at both departments of informatics at the University of Zurich and neuroinformatics, also University of Zurich and the ETH Zurich, where he does research at the intersection of robotics, computer vision, and neuroscience. More about this. And he led many projects, published many papers, written books, and founded also companies in the robotic field. And now he's here on stage to talk about his research and also the spin-off. So please welcome him, Professor David Scaramuzza. Welcome. Nice to have you here.
Is it working?
Yes.
Now it is. Thank you very much for the introduction and for inviting me here. As you can read in the title, I want to talk about how we can build autonomous drones that can one day possibly outperform human pilots. So if you read the latest drone reports, they actually claim that the drone market now is quite large. It's worth $24 billion US. And the most profitable markets are actually inspection of difficult infrastructure like bridges, agriculture, also counting fruits or spraying pesticides, transport of goods, and finally security and monitoring like search and rescue applications and more. But what actually they don't say is that all the autonomous drones that you see out there are either controlled by GPS or they are not autonomous at all. In fact, they are controlled by human pilots. So actually 99% of all commercial drones are controlled either by humans or via GPS. Now, humans are still the most used, in fact, because they are unbeatable. They are really great at controlling drones, and I will show you later in the videos what I mean. However, the problem with human pilots is that they take a lot of time to train, usually months or even up to a year. And the other problem is that they require a direct line of sight between the operator and the drone. So on the other side, there is GPS-based autopilot. So the drone can in principle fly by itself, provided that there is GPS. And that's where actually the problem comes. Because what happens when there is no GPS, like when you, for example, walk outside here, there is very little GPS coverage. That means that actually drones will not be able to operate outside of this building. And when GPS actually fails, what happens? Well, then drones crash from the skies. Switzerland was the first country in the world to allow autonomous operation beyond line of sight of drones to transport deliveries of goods. They started in Lugano in 2017, then Bern, Zurich, and they performed more than 5,000 flights autonomously. So because they were the first, they were also the first to have autonomous drones crashing from the skies. And the first crash happened in January 2019, and the second crash 3 months later. So the Swiss Post actually had to suspend the operation for like more than a year. Now they just resumed it. But at the origin of the crash was a GPS failure. So the question is, can we have autonomous drones that can navigate without GPS? And the answer is yes, of course, doing like we humans or animals do, using cameras, their onboard eyes. And this is what I mean. Basically, this is one of our drones. So we have the eyes here on the bottom. You can put one or multiple cameras. In this case, this drone has actually 4 cameras for different tasks. And then we have the brain, which is basically a very powerful computer. This drone is actually quite small, like about 20 centimeters in size. So when a drone relies on cameras to fly, so we call this a vision-based navigation. And actually, it's a quite new technology, and most people don't know about it. It actually started 12 years ago as part of a European project. And let me tell you a little bit about this story. Here you see how the drone navigates only using a camera. We only have a single camera. The camera is looking down at the floor, and when my student actually moves the drone goes back to the starting position, because at the moment it's trying to hover stably in the air. How does it work? Basically, the onboard computer analyzes the images and extracts some salient points. So some points that can be used as anchor points, like reference. And then when my student moves or disturbs the drone, the onboard computer analyzes the motion of these anchor points, and then it computes how much it should move back in order to stabilize the drone to the original position. So now you can use the same technology also to tell the drone how to navigate, for example, among obstacles to go from A to B. So that's the underlying basic idea. We started this 12 years ago, and we were the first to demonstrate the vision-based autonomous navigation of a drone in 2009. We participated in a competition where we wanted to fly a drone from the floor to a small house inside a university gym. However, at that time, 12 years ago, we didn't have enough computing power to do all the processing of the images on board, so we used a 20 meters long USB cable that was connecting the onboard camera to that laptop over there on the floor. And also the regulations didn't allow us to fly freely in a university gym, so we had to actually secure the drone with a fishing rod. That's why my student is securing the drone with a fishing rod. And then there was a moment where basically the drone was to pass through a window. And here basically was the end of the demonstration. But this was actually the first really, truly vision-based autonomous flight. What happened then? So after the end of the European project, actually DARPA was inspired by this project. DARPA is the Defense Advanced Research Project Agency of the United States of America. And in 2015, they launched the first program to investigate the use of cameras for autonomous navigation of drones without GPS. I was lucky actually to be part of this program. Only 3 members were part of this program. And the program ran for 3 years. It was called FLA, Fast Lightweight Autonomy Program. It was not top secret. Actually, we released all the publications publicly, all the code. So anyone can use it. And here you see what we were able to perform after, 6 years from the European project. We were able to have the first drone even exploring a forest and entering a house, all completely autonomously. Where do we stand today? Well, today is 2021, and we have actually autonomous drones doing vision-based navigation on Mars. So this technology basically was inspired, by an idea that we had 10 years ago. And now what's next? Well, the real big challenge is to make drones navigate as good or maybe even better than human pilots. What you see in this video is not an autonomous drone, but is a drone controlled by a human pilot. So there is a camera on the drone that transmits the images very quickly to some goggles, and then the brain processing the images, and then it sends control commands through a remote. But what is impressive is that humans can actually, fly drones in very cluttered and very challenging environments like this. So can we build autonomous drones, or actually can we build an alpha pilot, so a software that can actually analyze the onboard images and control the drone autonomously as good or even better than a human pilot? That's a big research question that we're facing now. But why? Why do we want to fly better than human pilots? The reason is the following. At the moment, all the search and rescue operations of drones that you see out there in the news, they are performed by human pilots, not by autonomous drones. The Fukushima decommissioning of the nuclear power plant will take 40 years to be performed, and there are humans behind those robots. The building that collapsed in Miami this summer, that killed 100 people, was then monitored by 9 drones, all controlled by humans. The Twin Towers attack, the 9/11 attack, was also, investigated by human pilots. Why were autonomous drones never sent there? Because it's too difficult to navigate drones in search and rescue environment. They're just too difficult. And there is a problem with human pilots that cannot go too far because they rely on signal transmission. So usually 200, 300 meters. So what about Fukushima that is actually over kilometers? There is another problem though. Drones can only fly for 10 to 20 minutes. Now, if I want to explore all this building in 10, 20 minutes, there is one solution though with the same drone. It's to fly fast. If you fly fast, you cover longer distances. So that means we need to fly better than humans, more agilely than humans. And if we can do this, we will also enable, flying, for delivering goods and exploring unknown environments very fastly and very efficiently. So that's the whole idea that we are working on. What's now the recipe behind achieving superhuman pilot performance? Well, the idea is to use artificial intelligence. What is artificial intelligence? We read often in the news, but very little people know. So artificial intelligence consists of programming the robot by examples, which means show the computer what to do without explaining how to do it. So basically the idea is that you show, for example, the robot a series of simulations and how to behave in a simulation. Maybe a human can show it, or maybe a sophisticated algorithm built by a human can show it. And then the algorithm learns to imitate these examples at best, and maybe even improving itself over time with experience. So we started doing this already 4 years ago, and one of the first experiments that we ran was a drone that used AI to imitate cars and bicycles. Basically, we had a drone that learned by watching YouTube videos how to fly, but not videos recorded from drones, but videos recorded from cars and bicycles. So we had to tell the AI program how to adapt what he learned from cars and bicycles and transfer that to flying. Scaramuzza. Ah, yeah, okay. It's okay. Slide 13, yes. Another example, in this case, instead we use the AI, we combine with a very fast camera to dodge objects thrown at the drone. So here my student is launching a ball, and the drone is flying at 10 meters per second, so 40 kilometers per hour. And then with this special camera, we were able to detect the ball and to trigger an evasive maneuver to avoid it. More recently, we started working on autonomous drone racing, where the goal is to actually beat a human at a real competition. In this case, the human is the red drone and the autonomous one is the blue drone. Still, the human is a little bit faster, 0.1 second faster, but we're almost there. And actually, this is our human pilot. His name is Marvin. He's only 15 years old. It happens actually that the youngest are also the fastest human pilots. And this should not be a surprise because they have the fastest reflexes. This is another recent work where we used an AI to teach this drone how to fly acrobatic maneuvers. Now, what I want to say is that in all these videos that you just saw, there was an AI behind. But how did the AI learn to fly? Did you actually fly all these drones in the skies or in your lab? And how many times did you have to fly? Actually, this is the problem. In order to learn how to fly, we actually needed thousands of flight hours. Means months. We didn't have this time. None of my PhD students have this time. So how did we do it? We did it in simulation. Simulation is fast, it's cheap, and it's safe. We actually simulated thousands of hours of actual flight in just 4 hours by simulating hundreds of drones flying in parallel. For each drone, we had a GPU, a specific unit in the PC, in the computer, that was simulating a specific drone. So here you see all the possible drones that we simulated. On the left, you see what we simulated. On the right, you see how it performs, like in simulation. The big challenge, though, is to make simulation as close as possible to reality. And that's what we are working on. And now, what's the next key challenge for today's robots? So we've seen that, we are pushing the performance in order to beat humans one day, but the real challenge will be to get drones able to enter this rubble. What you see here is a picture of the famous Miami building that collapsed a few months ago. How can we get drones into the rubble? And the only way to get them into the rubble is to make drones smaller and smaller, like this one over here. But the smaller the drones are, the more stupid they are at the moment. Because at the moment, sophisticated and powerful computer needs to be large and bulky and heavy. So the real challenge is to actually now make this algorithm capable of running on tiny drones like the one I brought over here today. That is this small. And this drone has 2 cameras and a small computer. So that will be the next big challenge. And with this, I would like to thank you for your attention, especially all the people behind and our sponsors. Thank you.
Thank you. You can keep it for now. You can also sit down if you like, because we're about to start wherever you... Yeah, perfect. That's fine. Wow. Thank you. It's been so interesting, so many information. I imagine you're feeling the same right now. But we're going to dig deeper in our panel now. So please let me welcome to our panel as well Dario Floriano again. So, and you may sit there if you like. And also we're welcoming Francine Zimmermann. She works at the Federal Office of Civic Aviation, the FOCA in Switzerland, and she's responsible for developing the strategy, policy, and the international regulations for all those emerging technologies such as civil drones and UTM. So she's the perfect expert for this, and also she co-leads the FOCA Innovation and Digitalization Unit. So she's also very involved in this new technologies and digital airspace. So welcome, this is your applause. Nice to have you here. And from Germany, we are welcoming Simon Kumm. He is the CEO and also a drone pilot of Inspec Drone GmbH. It's a company that is based here in Stuttgart, and they are doing plant and power plant inspections using a special confined space drone. What exactly that is, we will find out. Welcome. So, very nice to have you all here. You all have your microphones. Yeah, perfect. You also have water if you need this. All right. So, I said in the beginning that a lot of experts are saying that this decade, the 20s, are going to be the next big golden age for flights. What is your opinion as an expert? Are we going to have a golden age of flight, Dario? Oh, you don't have a microphone, sorry. Yeah, it would be good if you two share and you two share. Okay.
Well,
yeah, it's on.
So in a sense, we already have a golden age. I think the answer should come from Francine, because we have all these beautiful things in the labs, and sometimes you can make companies, but then we cannot fly all the time. In Switzerland, it's very permissive, but I think regulations and public acceptance is one of the roadblocks, maybe, from my perspective. So I would like to know what Francine thinks about this.
Well, Francine, what do you think about it?
Thank you very much. That's a very good question. I think, we have already daily drone operation in Switzerland, but it's only, some operation. And for me, really now the next step is how to scale. Because the industry, okay, here we have like research institute, but we also have the industry, a lot of industry players in Switzerland. And at some point, they also need to make money and to have business. So for me, really, the next step is now how to scale. We have been, as I said, very open to enable those operations. We have the chance that we have a research institute like APFL and ETH and also other in Switzerland. So as a regulator, we can be either enabler or we can hinder innovation. We chose very early that we want to enable this, but now I think we really need to go one step more and really to scale. So that's for me the goal the next couple of years.
To scale it. But talking about scaling is already a really good thing, because I think some countries might be even less, and this is exactly what in your presentation really struck to me in the end when you said we must first understand technology before we regulate it, which has been said. Is this something that you also would say, yes, this is something
Yes, of
I
course.
think as well.
Yes, I think it's key, and that's why we launched almost 3 years ago a private-public partnership called SUSI, Swiss Space Implementation, and it was FOCA, so the Federal Office of Civil Aviation, together with our ANSP Sky Guide, and about 30 industry players from everywhere, from the US, from Europe, from Australia, everywhere. And we really said, okay, we want to understand, so regulation is not here yet, so it's coming. Now we have in Europe regulation, but it's still at the early beginning. So we said we really want to test the technology, to understand it, and then to do really good regulation, and taking that into account. So we started that 3 years ago, and it has been really useful for everybody. So it's on a voluntary basis. Everybody who wants to join can come, and we test the technology. So yes, I fully agree with what also Ms. Leutard said and what Dayo mentioned before. It's really key for us and for the whole community that we go that way.
Before we go deeper into regulations, because I think we do have to explain a little bit more what kind of regulations there actually are at the moment. But Simon, I'm looking to you first. So my question about the golden age, what do you say, being a CEO of a drone company?
Okay, I can only speak for a very special part of the drone flying, because where we fly, we are not regulated. So, sorry for that. We fall out of this area. But I would join this opinion that we are on this path where a lot is possible, but it needs to be. A lot is technically possible.
Yeah.
The scaling really, you have various partners. You have the industry. From our experience, it's already, for some industries, a problem to accept new technologies. So you have like you said, the public acceptance. You also have this, not only for the public, but for companies also to realize, okay, there is a new technology, we have to implement it, or we have to see how we can work with it. But everything has to go together. So regulation, acceptance.
Definitely. It's exactly what I was wondering, listening to your two presentations. I was wondering, is actually the problem now the regulation or the technique? Is it still not developed enough, or do we have too much regulation? It's exactly what was going on in my head, David.
So I think it's a problem of both. Now, depending on the country, one can be more dominant than the other one. Certainly in Switzerland, it was the first. It's very open-minded, and so it's possible to test new technologies that in other countries would not be really possible. So it was the first country in Europe to authorize beyond visual line of sight autonomous operation of drones. So they started with the Swiss Post and also with other services. In Africa also they allowed that. In Rwanda, in Ghana, for example, there is a company that is flying blood samples 25 kilometers away with the fixed-wing drones. But the US was also one of the last countries, actually, surprisingly. Now they're actually starting. So countries that actually have low income, surprisingly, were the first to authorize visual beyond line of sight autonomous drones because they needed it. So that's the need that drives, in the end, the acceptance of them. Now, in Zurich, for example, there were a lot of public complaints from people about the drones flying between the university hospital and another lab, because they were flying sometimes, occasionally, over houses. So, however, they were flying over during the day. But some people complain about the noise. So noise is actually now a big stopper, for example, if you want to use drones for delivering goods within cities. So we have to wait and see. Of course, there is a lot of research that needs to be done in order to reduce noise. We know how to do this. You need the smaller drones. But then you cannot, for example, lift very heavy loads. There are also active noise cancelling technologies, the same ones that we use for our noise cancelling headphones, for example, that can be used, but they are still confined to research labs. And then there is safety. Safety is another problem. 2 drones crashed out of 5,000 autonomous flights in Switzerland. What is the other companies that is actually scaling up a lot is Zipline. They did more than 200,000 autonomous flights in Rwanda, but they are using fixed wings. Then the worst case scenario, they don't fall down vertically, but they glide. so they're safer. So quadrotors are still, a big concern if something goes wrong. But there are already technologies that can prevent them from crashing if a rotor fails, if GPS fails. So, but we need to basically first see whether this technology is mature enough to be deployed.
Okay. With the noise, I don't know if you've ever been here before when our drone and our drone parkour is flying. It is very, very loud. Makes working or talking quite impossible. So it's interesting to talk about this. Talking about regulations. So what kind of regulations do we need to also ensure, obviously, safety, but still that the technology is still further developing? What kind of what kind of regulations? Where are we at the moment in Switzerland, and what would you say? What do we need as well?
So the key that we need is really a risk-based regulation. So performance-based and risk-based regulation. So Professor Scaramuzza mentioned the two incidents that we had with one of the drone. I would like here to say that yes, the drone they fall from the sky, but we had mitigation measure in places, and everything happened how it should happen if the drone is out of control. So it was incident, but nobody get injured or so nothing happened. So of course we are not saying that. So we are allowing those operations. So we need to be confident that it's safe enough, that it's good. But we are not saying that drone will never fall from the sky, because I mean it's like everything. I mean it can happen. But the idea of this risk-based approach that we have in Switzerland, but also in Europe and also in the US, are working with that as well, and in China as well, in Australia, almost worldwide, is really to work with mitigation measures. So we have several layers of mitigation measures, and given all those layers, we can be confident that we can fly safely. So if one of the layers will not function, we will have another.
Yeah, but still, I've heard that in Switzerland the regulations are a bit, well, not as stringent as like in Germany or the rest of Europe. What can you say about that?
Yeah, so that's a bit a tricky question. So actually, there is an harmonized European regulation on drones, entered into force 1 year ago, around 1 year ago. So it does not apply to Switzerland yet. So we have some discussion in the parliament. So we were not able to take that regulation, even if we have a bilateral agreement on air transport with Europe. So we are supposed to take over this regulation. So we are not, I mean, it doesn't apply to Switzerland. However, I was personally at old meeting 5-6 years ago when we started to write those regulations. So meaning today we are already very similar to what the rules are applying in Europe. You mentioned Germany. I think Germany has a complexity that is maybe a little bit similar to Switzerland. In Switzerland, you have the cantons that have also some right, and they can decide things. I think in Germany it's even more complex with the Länder. So
absolutely.
Yeah. So I guess maybe the question from that, and maybe also the issue, the challenge. Maybe given the fact that we started very early, I mean, Professor Florano mentioned 2009. I remember, and I was not there, but my engineer then, they told me the story in 2009 when they came to us and said, we would like to fly 15 drones in BVLOS, in vision, beyond vision line of sight. And we were like, what? How can we allow that? But we didn't say no. And so given the fact that we start very early, I think we had the time to really to experiment and to learn based on really practical examples. So maybe, I don't know, in Germany, I mean, I'm sure Simon know that better, but maybe they didn't have the chance to try many things, and maybe they just need a little bit more of experience.
Maybe we just need a bit of time. What do you think, Simon?
Yeah, we need time, and of course we need people who go forward, who push the limits and maybe test out what is possible. I'm not the expert for laws here, because we rarely come into contact with that, but everything that I know from others who are flying, it's not that easy. Especially when we talk about startup companies. In Germany, as you mentioned, you have the Bundesländer, and for every Bundesland you need more or less your own license to fly, or you need a permit in each of the 16 Bundesländer.
Nice.
So yeah, great fun. If you want to offer any flight services German-wide, you need to cover all of them. And of course, it's an additional fee in every Bundesland. So, yeah, it's
Nice.
not easy to get into that field. So,
I get it.
yeah, I mean, it's not the biggest hurdle to go over, but sure makes it a bit more difficult.
Definitely. But I was thinking as well, isn't it like with every new technology? I mean, back then, you know, when cars were new, nobody wanted to get into a car because it could be crashing and dangerous, and then we had planes and everything. So isn't this also just this acceptance just needs, you know, it just needs a bit more time? Or Dario, what's your opinion on this social acceptance, and how can we also achieve it? How can we get drones into being more normal around us?
Yeah, I think you're right. It takes time, and I think young people, as many here in the audience, I actually would like to know their opinion. But when I see the students, they are not particularly concerned by the technology. There is an issue maybe of privacy. Maybe that's a topic, but not particularly concerned, I think. Yeah. So I think it takes time, and. But it's true that if we have accidents, and those accidents are so far they were not problematic, but if in the future they are problematic, that could block social acceptance, and then there would be limitations to what the companies can do.
Does anyone have a different opinion on this? All the same?
Maybe I can add one point. I mean, social acceptance is a big thing, but I think we need to really to tell people what we do with those drones. Because, I mean, we had the example of the blood sample in Lugano and in Zurich. And, I mean, in Lugano now, as Professor Scaramuzza mentioned, we started 4 years ago there back in 2017. And I was there 2 weeks ago, because now they have like a station, and because they want to be more autonomous, they have it's like a floor where the drone can land there, and I was there to watch that. And the people in Lugano, most of the people, they know about the drones, and it's really well accepted because they know they are doing useful things. So I think here, if we tell people what we do with the drones, they will accept it. I'm sure, I'm really confident, but we need to involve them.
Yeah, maybe I just want to add something. Why are drones so special? Why do people concern so much? And probably it's the only instance of a machine that moves without a human. So you don't see the human. It's like, imagine you see one of these Tesla cars, and you don't see a human sitting on the steering wheel. You would be very concerned too. So that's probably the reason why. At the same time, when you think that you fly on a jet, and then the pilot is not controlling anything, is just sitting there, it's a very similar situation, and you're sitting up there. So it's probably a matter of, as you say, making sure that people understand what these drones are doing. Today, probably a lot of people say, well, there could be a human somewhere, there could be no human, there could be a kid, there could be no kid. Probably that's the situation we are in. But as if it is regulated, things will change, I think.
Okay. Sorry, did you want to add something?
Yes, one thing, we talk about the future now, but the current state is always hard to break through. I mean, you are working at a university, you are doing research for future projects. I think it's a bit different there. You have always new students, you have young people, you have new ideas, you want to go forward. From my experience, it's a bit different in the industry, because by the time that you have someone in a position to make decisions, they are usually already a few years into their job, and they tend to do things, of course, as they have always been done. I think it's a problem in every field, but we sometimes really need, like the example with blood samples, or with really good examples to show people, yes, it makes sense. Use drones, they have good use, to just open their eyes. Because not everyone is as open-minded as researchers at universities.
totally agree with you. So let's open some eyes and let's talk, maybe you can keep the microphone. Let's talk about some use cases that we already have and what kind of industries. We already seen some examples, what is already possible, what is happening, but you have something a bit different. We have seen that a little bit, but maybe we can go deeper into this. What exactly your company is doing. It's not regulated where you fly, I already heard that. So
99% is unregulated, I would say.
Okay.
Yeah.
So tell us.
Yeah, I will. So we're operating a drone inspection company, and we're specialized in inspections for confined spaces, meaning everything from boilers, power boilers, to flue gas stacks, to large vessels, to underground ducts like sewers. And yeah, we are based here in Stuttgart, actually. I came by Straßenbahn today.
Me too.
Yeah, but we operate German-wide, and yeah, we often have this topic of bringing new technology to industries which are very traditional. So cement industry, wood production, chemical industry, very traditional in Germany. Yeah, it's not that easy to bring it to them. And we actually use the product which is usually displayed right next to this panel stage here, the Ilios 2 from Flyability. Dario already had the grandfather, I would say, of our current drone in his presentation. I mean, it takes a very short time from generation to generation with drones, other than with humans. So I think when did you found, or when did Flyability leave university? 2012, 13?
So that was 2015.
Oh.
Yes.
So you just
Okay.
saved yourself with that comment, you know?
But yeah, from I mean, I think it shows very well how quickly the technology evolves. I mean, the company was founded in 2015 with the development of the first version of this inspection drone. Now we use the second drone for the second year now, and we're currently in cooperation with the with Flyability to develop the third iteration. So everything moves really fast.
Maybe we can show the audience as
Yes,
well a little bit something.
In addition to the video we saw earlier in the presentation, we have a short one here to show you what we can do.
I'm not sure if we have audio, otherwise you can explain as well. Ah, we have audio. Okay, perfect.
Mein Name ist Simon Kumm, ich bin Geschäftsführer der Inspect Drone GmbH. Wir setzen die Ilios 1 und auch die Ilios 2 von Flyability ein, um in Industriebereichen Inspektionen für unsere Kunden durchzuführen. Was ganz wichtig ist für den Kunden hier am Standort, ist das Thema Arbeitssicherheit, und hier kann natürlich die Ilios 2 von Flyability einen riesen Vorteil bieten und ganz klar punkten. Der Grund, warum wir heute hier in der Anlage sind, ist, dass der Kunde mit Hilfe der Ilios 2 von Flyability die Stillstandszeiten verkürzen möchte und eben die Anlagenteile zugänglich machen, für die sonst ein komplizierter Einstieg erforderlich ist. Die Inspektion in dieser Anlage wurde bisher manuell ausgeführt, das heißt durch Einfahren in die Anlage, und in manchen Anlagenbereichen musste man einfach warten, bis man auch von außen was gesehen hat, weil die komplett unzugänglich sind. Die Vorteile, die die Ilios 2 bringt in solchen Anlagen, ist hauptsächlich die sehr viel bessere Ausleuchtung. Dadurch kann man sich einfach deutlich besser orientieren. Die weiteren Vorteile der Ilios 2 liegen natürlich in der deutlich verbesserten Bildqualität und auch in der Stabilität im Flug, wodurch man kritische Stellen noch besser orten kann. Die Reaktionen der Kunden sind generell sehr positiv. Bei den meisten steht im Vordergrund das Thema Arbeitssicherheit, was eben hervorragend durch diese Drohne unterstützt wird. Die Schlüsselpunkte für die Kunden sind zum einen die Möglichkeit, Stillstände zu verkürzen durch eine schnellere Inspektion und zum anderen die Steigerung der Sicherheit. Durch den Einsatz der Drohne kann eben der Einsatz von Personen in Innenräumen reduziert werden. Ja, die Zukunft der Inspektion in Deutschland, in Industrieanlagen, da sehe ich ganz klar Drohnen als einen wichtigen Teil im Rahmen der Automatisierung, der Digitalisierung.
Not our logo. Actually, we did this video together with the manufacturer of the drone, Flyability. I think it was beginning of 2020. Yeah, shortly before Corona. So yeah, we could still meet there. Yeah, I wasn't actually aware that I talked about the future of inspections there, but I think it's a nice touch. And yeah, what I wanted to point out is that what we saw earlier in the presentation, the drone that had no GPS and flew through the woods. Actually here we also have no GPS with the latest model, but we have like the early version of this navigation using visuals. So we have cameras sensing motion, we have distance sensors. That's why the videos, some of the videos were taken with this drone. So we had two on site to follow each other. It gives a really good stability. I think it's only a first step towards what you're researching, but it shows that it's already making an impact on real world use. It's not just academic, it's not just someone imagining something, but it really has a huge impact on industries.
Sorry, did you want to say something?
No, I would like to take the opportunity to say that actually indeed the vision-based navigation now is becoming more and more mature. There are already many drones, especially the DJI drones. So DJI is the world's largest drone manufacturer from China, Shenzhen. That actually all their drones have multiple cameras, at least 6 cameras to do obstacle avoidance omnidirectionally, automatic takeoff and landing. And also there is another company from the US, the largest in the US, it's called the Skydio, that actually has also multiple cameras that they can do autonomous inspection as well. So basically the drone decides where to take pictures in order to get the best 3D model of the bridge or of the wall that you want to inspect. So this is also, you know, already entering the market, and we will see more and more. But now the real future will be to get them smaller, safer, so that they can get close to individuals, possibly with cages, and they have the human less and less in control of these drones. However, the drone can still be, you know, requiring some high-level input from a human. That's what we would still call a level. So there are 5 levels of autonomy, typically in automotive. And now these 5 levels of autonomy are coming also to drones. Actually, just last year, they were for the first time categorized. And so the first level of autonomy is called 0 level, means the drone is completely manually controlled. Then let's jump to level 3. It means it can do takeoff and landing and some easy obstacle avoidance. Level 4 means that actually the human only gives waypoints, and then the drone passes through these waypoints. But level 5 is that the drones does almost everything, and the human actually gives a high-level description of the task. For example, enter into this building, map it, localize the survivors of the earthquake, come back and return to me a 3D map with the position of the victims. We are not there yet, but that's you know the thing that we are going to have soon. Okay, so it's a matter of time, and people will accept it, I'm sure.
Are you also using artificial intelligence in your field as well?
We did the first tests with this, especially it's also a Swiss company, of course, they provide an AI that can inspect sewers. So where you your wastewater goes through. You can automatically identify like cracks, and you can it basically gives you a full report that normally you do manually.
And nobody really
So
wants to do
it's
that.
highly interesting. The combination, I think, of AI and drones, or computer learning, however you want to call it, is definitively part of the future. And I mean, you noticed with the which I'm not sure in which presentation it was, the drone with the USB cable. Of course, you can replace the USB cable once you have more powerful computers using less energy.
But then again, the German person in me pops up and it goes like, okay, drones already really bad. And then
Yes,
we also
they
have
are.
artificial
They can be,
intelligence.
yes.
Oh my God, what do you say as being a regulator? How do we solve this then? By the way, I'm not thinking like this, it's just me being German.
Yeah, maybe I want to go one step back because we were speaking about a lot about drones and how can we make them autonomous. A very important topic we are working on, I mentioned at the beginning, SUSI, the Swiss Space implementation, is to digitalize the airspace. Because currently, I mean, of course, manned aviation, we have people, I mean, looking that the aircraft, they don't collide, right? But we cannot have this for drones. So you cannot have like one person like checking that the drone, they don't collide. And as we are not there yet, that they are autonomous and intelligent, that they avoid themselves, we are working on bless
Sorry.
you.
Sorry.
We are working on how to digitalize this airspace. So we are starting at a very low level. And because you may know that at European level, we will have a U-space regulation starting early 2023. It will enter into force with a couple of U-space services. So it means how can we automate, like how we can have like network remote identification, so that it will help also the acceptance, because the general public can then know who is flying here. The drone, they can also spread information about why they are flying here. So everything will be connected. So we are really working on that now with the industry and with our ANSP. So I think this is also one way. I mean, there are the drones, but also the air traffic management that need to be digitalized. And AI is, I would say, the next step. It will come for sure. I mean, it will come. So I'm sure of that, and I think it's also a good development. But we need to do one step after the other. Otherwise, I mean, the public acceptance that needs time.
I would really love to have a German regulator here on the panel to see if there is the same openness. And before I ask a final question, I would like to turn my head to our wonderful audience. If you have any questions to our panel, and yes, we are coming with a microphone. It will just take a second. Michaela, if you could be here to the front. Here. She will hold it for you, or not. Yeah.
Okay, thank you. Thank you very much for your talks. I wanted to ask something. So it looks like on this way to these small insect-like drones, this problem of very lightweight and powerful energy sources is like one of the major ones. What do you think are the prospects in this realm in the nearest future?
So there are several possibilities to counteract the energy shortage. So there are already, although not commercially available, sulfus, what is it called? Polymer batteries that would be able to extend the duration of a battery. Then there are also fuel cells that could also bring the duration from 20 minutes to up to 1 hour for a common quadrotor. However, again, they are not commercially available. They are quite bulky. Now, you have to think also that there are not just multi-rotors around there, so quadrotors, hexacopter, octocopter. There are also fixed wings. The reason why, for example, zipline uses fixed wings is because they also glide, so they actually need much less energy. They can fly for more than an hour. So that's also something to take into account. So depending on the application, consider a different drone. Another thing to say about energy is You can now, with the arrival of 5G, since the latency of 5G is promised to be below 10 milliseconds, you could in principle offload a lot of computation, especially reconnaissance and mapping that are very energy hungry, to the cloud. That means a drone only does very little things. So still, of course, 90 to 80% of the power is needed to fly, so that you can only save a little bit. But that's something that you can consider. Then the only issue will become, okay, but we are relying on a cloud. How do you maintain connectivity with, within a building that is very far away from the base station? So that can be done by creating like a network of drones. So like Dario was saying, you could send a swarm of drones, each one communicating with one another, and so this multi-hop communication can then ensure through a chain of drones communication with the base station. So that's one way also to see that. Of course, there is another last resort, which is a beaming energy. It's called laser-powered energy. So there is a company called Laser Motive in California that has a huge laser pointer, this big, can transmit 100 watts. So a typical drone, like the ones we showed in our presentation, consumes 100, 200 watts. So you can stream that up to several kilometers. Any bird flying into that would be cooked almost instantaneously. That's the only problem. But it's already being used. Actually, there is a video from more than 10 years ago on YouTube where they did a 27 hours autonomous flight inside a building, with this laser power technology to demonstrate that it's feasible. So it can be used, for example, to use drones to survey fires in California and other places, especially during hot times.
Yeah, I think you cover most of this. Just want to add a couple of things. One is related to what you said. There is a lot of energy in the environment, and we can use that energy. So if you look at birds that fly long distances, most of the time they just use thermals or they use wind gusts. And that requires, however, information about wind speed that we today cannot yet get from the pitot tube, these airspeed sensors that we have on board. So that's a research line, for example, that we and other people are currently pursuing, how to make this long-range flight. The other thing is energy harvesting. Actually, in a project at the moment, and David is also part of that, it's a European project. We are looking at drones that can land and grasp power cables, and they have a recharger on board, they stay in there, and then when they are recharged, they just take off and they fly again. So, and there is plenty of energy out there. So a problem is going to be a combination of all of this. I'm not expecting batteries to have the magic solution. All of a sudden, there is a breakthrough. But the combination of all of this, I think, is going to be fine.
Is there another question from our audience? Yes, all the way up there. So
you mentioned that there are attempts to improve crash safety of drones. It's hard to imagine how this works for drones with rotors. Is it like making the systems more redundant or adding a parachute or something? What are the possible ways to improve this?
Parachute is the first thing, and actually many drones already have, but it occupies a large space, so you need a large drone, which means it's also heavier and so more dangerous, of course. So the company that is operating in Switzerland for the Swiss Post actually uses parachutes, and it's deployed when there was deployed when there was a crash. However, for example, the second crash, what happened is that the parachute was deployed in a situation where it should not have been deployed, and then it got tangled with the rotors, and then it went down. So in this case, when a drone goes down, I would say the only possibility is to open an airbag, for example. But I would say that these are very rare scenarios, okay? So we are still observing the technology in order to learn and how to mitigate this. The other thing is how to prevent them from crashing. So actually, you don't need to have 4 quadrotor. So a quadrotor doesn't need to have all the 4 propellers operating to remain in flight. So there are already control algorithms that have been demonstrated more than 5 years ago in the research community, and some of them have been sold already out there, that allow you to remain in flight with only 3 propellers. Now the chances that two propellers fail is really, very, very small. So we care only about one propeller. But in general, a safe multicopter would be a one that has at least 6 propellers, because then if one fails or two fails, you always have the other 4 and you can remain stable in flight. If you have a quadcopter and one fails, then quadrotor starts spinning on itself, but you can still, land safely out there. However, what about GPS failure? So all the drones that commercially operate use GPS. GPS is blind. It's like navigating, you looking at Google Maps without looking around at the people around you, right? Makes no sense. But this is okay, it's allowed because there are not many drones out there. But the moment there will be many drones and you are navigating cluttered environments, cities, then you will need also obstacle avoidance detection and so on. So these things, they will come, it's just a matter of time.
Thank you.
That's completely covered your answer. We do some experimental work on making drones soft. And actually, there is a small exhibition behind this wall. You can see some of our early prototypes. So the idea is that you have drones that when they fall, they are like sponges. They can absorb the collision. They don't mitigate it entirely, but they don't, for example, make a punch in somebody's skull. But this is again research, so probably will take some more activity to make it a product.
So interesting. Thank you.
Sorry. One thing I want to add is I think we also have to change a little bit the perception of drones, because when you go outside and there are cars driving, they're much more dangerous than any drone. So maybe it's also a bit maybe public education. What can a drone? What can happen? I mean, usually drones don't fly over your heads. They fly over a field or maybe over a street. But if two cars crash into each other, it will be worse than a drone crashing into a car, probably. So, but of course, research needs to be done, as always.
Okay, there's one more question over there.
Thank you. I have a question actually on a related topic, and it's about noise and public acceptance. So actually in the sky there are already millions of publicly accepted and very silent objects, right? These are birds. And the question is, do you think that certain biological inspiration or similarity would lead to, let's say, better, noise rates and public acceptance? Because even if you look at the Spot robot, for instance, the walking autonomous robot, right? This like dog-inspired shape, I think it plays certain role in being it more, accepted by public compared to, let's say, wheeled mobile robots. And I'm fascinated by these very dynamic bird-inspired designs that Dario, you were showing. And the second half of the question, do you think that will also help with reducing the noise and increasing the payload for drones? Thank you.
Yeah, so for these feather morphing drones, they are relatively silent. We use just one propeller. We still use one propeller because of research questions. So we are studying the role of morphing in agile maneuvers. And so I asked my students to not flapping the wings as well, because that from a research perspective, we change one variable at a time. But we are already studying the possibility of flapping the wings. And there are some companies that make flapping wing drones. There is a Dutch company, for example, using these drones for scaring birds away from airports. And they are relatively silent, indeed. And as Davide was mentioning earlier on, these drones also allow you to glide a lot of time. There is a lot of research still to be done to make them lightweight, to approximate the lightness of feathers and also the sensitivity that feathers in birds have. They have neuromuscular sensors that allow them to judge local turbulences, which today we do not have in drones. Today we rely on this inertial measurement unit, which is sitting in the central part of the drone. So yeah, there is a lot of research, and probably there will be mitigation in noise as well.
Thank you. That's great questions. Is there another burning question? Yes, please.
Thank you. Yeah, it was really interesting to see all this presentation. It's really exciting. And I have a question a bit about the outlook, because you said like the goal is to achieve like a 5 level of the autonomous. And I was curious about that drone, which was made like inspired based on the bird. And as far as I understand, like the level number 5 reduced the human impact. And I'm curious about the proprioception, the type of the proprioception, because like if you look for the birds, there is they solve this solution, and I'm curious about if you will continue to use the video tracing, or it will be possible to mimic some kind of bird sensing.
Okay, so maybe here I think both of us can answer this question. It's a very good one because it's what we're working on. We are working on artificial feathers that have proprioceptive information and are distributed throughout the body of these drones. So this is still very early research question that we are exploring in the lab. At the same time, as you have, imagine that we succeed, you have all this information that comes from these feathers, which we know still relatively little about how birds integrate all these signals and fuse this with visual information. That's where we have collaboration with Davide. We have a PhD student actually who is starting to work on this and applying some of the methods that Davide showed for his quadrotors to learn how to fly with these bird-inspired drones.
Simon, would you like to add? No, you just took the microphone. Okay, well, with regards to the time, one very, very quick last round. So you've shown, the last slide of your presentation was this overview of all the companies in Switzerland. There are so many. What makes Switzerland actually this really good place? What would you say? It doesn't have to be you, maybe David or whoever wants to answer this question as well. What makes Switzerland such a great place for this drone companies? Why are there so many in Switzerland? You answer first. I don't mind.
Well, I think I mentioned it. So there is a very nice research environment. So the research is really good, and there is a tradition of micro technology that exists. There's tradition in Switzerland, and I think much of the early prototypes that eventually turn into companies owe to this type of expertise. There is also a program in artificial intelligence that started back in the end of the 80s, beginning of the 90s, that brought neural networks and a lot of development, computer vision to Switzerland that also that helped this development. There is the Office of Federal Aviation that allows us to fly and do things that probably in other countries would not be able to fly. And then I think we have also the National Research Program. It's a 12-year program that the Swiss Confederation gave us in total with the local universities. It's almost 100 million Swiss francs to do research and technology transfer and education and equal opportunity, many things, but allows us to, and it's only a small fraction of the funding that we have because we all get funding from many different sources. But that program allows us to come together and to work together, and that's quite important. And then there is a lot of innovation, yes, and which is about entrepreneurship spirit in Switzerland, which is very pragmatic. Let's move on. Let's do something that has an impact.
Yeah, and Davide, do we have the right people? Are there maybe that's also this entrepreneurial spirit? Is that also one of your?
Yeah, exactly. That's what I wanted to add. We have excellent schools in Switzerland. We have EPFL, University of Zurich, ETH Zurich. We have ITSI and Lugano, which has invented the LSTM that are basically used in all smartphones today to process our speech. So there is all of this technology that's been there for more than a decade. We also have a very large concentration of robotics professors, I think normalized by the country's population. Yes, students are good, but also I would say that some Swiss academics were also the first to, for example, have flying robots. Professor Sigvart, initially at the PFL, demonstrated 20 years ago the first autonomous quadrotors, flying only about half a meter at that time. And then a few years later, they built a coaxial helicopter that inspired the Ingenuity helicopter that went to Mars. So there was always a little bit of aerial soul into the Swiss universities. But then certainly what What helped was especially the whole legislation, so the fact that basically it's much easier to get these things out in the air than in other countries. And I come from Italy, a country where basically, drones were very difficult to fly. I hear from all my colleagues, and they couldn't believe what I was telling them at the time. I could fly them freely and test them.
Definitely. Something.
If I may add
Yes.
just one sentence, I think the key is the collaborative approach. Really, the industry, the research institute, and also the government. And now we have a cluster. You show it, Dario, in his presentation at the end, the drone map. This cluster came, all those okay, of course there are startups, spin-off from ETH, from APFL and so on, but also a lot of foreign companies, they came because they knew, okay, there is this kind of like ecosystem, so we want to be part of it. So, and for me, it's really this collaborative approach that is key to everything, because the regulator, we are not innovative, so but we can listen to what they do, we can listen to what the industry needs, and then we can help them. And
and understand the technology as well. So working together, hand in hand, all the bodies. What about Germany? Would you say things are being pushed in the right direction? What's your future wish for your industry?
So I might want to add first that it's exactly what I think that makes Switzerland special, that the collaboration between regulators, between universities and the industry works. It's a little bit closer to the industry, but it's not so far away that you would say, okay, there's no research done. You do proper research, but with a good focus on industry. I know that in Germany for a fact it's also happening. Yes, we have very good institutions doing this technology transfer, but not yet as specialized. As you mentioned, you have so many professors for autonomous robots or for this field that it's clearly pushing in a certain direction, which of course helps. And it would help to have this in Germany as well, of course. Yeah.
Perfect. Well, I would say let's continue this conversation having a glass of wine in our hands. I would like to say thank you so much for this great contribution. I've learned a lot. I hope you feel the same, and it's been interesting for you as well. So please give a very big applause to our speakers. Thanks.